Hello, ladies and gentlemen, and thank you for joining me. We're looking at C2. Oops, wanted to underline that, not cross it out. C2 on our 2015 COMC paper. So let O be the origin, Q be 13, 4. A is going to be at AA, so it lies on the line y equals x. Just trying to mentally picture it. And B is B0, so it's somewhere on the x-axis. Okay. A and B are positive real numbers, okay, and B is greater than or equal to A. Okay. The point Q is on the line segment AB. That kind of constrains what A and B can do. There's a relationship between them. Alright, let's take a look here. A part. Determine the values of A and B for which Q is the midpoint of AB. Well, it's not that hard to find a midpoint. You just average the x-coordinates and average the y-coordinates. So the midpoint of AB would be A and A are the x and y coordinates, and then B and 0 are the x and y coordinates for B. And so we get a little something like this, but this has to be equal to Q, which is at 13, 4. So what does this tell me? It tells me A plus B over 2 is 13, and A over 2 is equal to 4. Well, this tells me A is equal to 8. This one tells me A plus B is equal to 26. And if I combine these two, we get B is equal to 26 minus 8. B is equal to 18. So we just want the A and the B. I would just put them together in a single box so it's nice and clear to whoever's marking, whoever's reading, that this is my answer for A part. Alright, flip the page to get ready for B here. Determine all values of A and B for which Q is on the line segment AB, which is something that was already told to us. But we also need to have the triangle OAB be isosceles and right angle. Okay, I think now I might want to draw a little bit of a picture of the situation. So Q is somewhere, it's 13, 4, right? Yeah, 13, 4. So somewhere way out here, 13, and well, let's say 13 and 4 here. So we'll say Q is about here. Now, A is somewhere on the line like this. O is something like is the origin, and then B is somewhere out here. So we get OAB looks a little something like this. Okay. So what can we say here? Well, we know, or rather we are told that B is greater than or equal to A. Okay? So we could have our right angle up here at A, although there's a possibility that we would get AB like this. Now, the right angle can't be at O because you automatically have a 45-degree angle between the x-axis and the y equals x line. But you could have your right angle over here at B, and that would just mean that Q is somewhere around here, and that A and B are both equal to 13. All right, that's possible. So what are we looking for? We're looking for A's and B's. Okay. But so what I would do is I would say break it down into two cases. So two cases. Right angle at A or at B. And if you wanted to, you could briefly explain why there's not going to be a right angle at O. I would say the 45-degree written in my little pictures here is perfectly fine. So we've already done one case. The right angle at B. That is to say AB perpendicular to the x-axis. That would be fine. Then if the right angle is there at B, then you might want to, if just because it's a C-part question, we do want to be writing things up. AB is of the form x equals some constant number. Now, usually I would say x equals a. They've already got that a in use, so let's say x equals k. We know q is on AB. Therefore, k is equal to 13. Therefore, a is equal to b is equal to 13. So that's one option. What about our other case? The perpendicular line is, or the perpendicular angle, the right angle is at A. Okay. Then what do we have? Well, then slope of AB is the negative reciprocal of the slope of OA. So that's going to be negative 1 over 1. You might remind them that the line y equals x is the line OA. So we get a slope of negative 1. Okay, so OB, AB, I don't know what's up with me today. AB, it looks like y equals negative x plus, and I'd use b normally, but we've already got a b in the question, so we'll say k. But we know q is on the line. So 4 is equal to negative 13 plus k. So k has to be equal to 17. Okay. So then AB looks like y equals negative x plus 17. So A is on the line. So A is negative a plus 17. So 2a is equal to 17. A is 17 over 2. And we know that B is on the line and has 0 y coordinates, negative b plus 17. So B is equal to 17. Just quickly double check, is A less than or equal to B? Absolutely. So we're good. And you could summarize, you could say either AB is 13, 13, or the pair is 17 over 2, 17. That would be perfectly fine. Okay. So that's B part out of the way. How about C? There are infinitely many line segments AB that contain point Q. For how many of these segments are A and B both integers? Okay. So once again, I think we're going to have to dive into a little bit of slope work, a little bit of line work. In the last one, we used the slope of negative 1, but now I think we're going to have to do a little bit more work with our slopes here. So, what should we say? Well, we know A is AA, B is B0, Q is 13, 4 are on the line. So the slope of AB can be calculated in a few ways. It could be rise over run like this. And we might even call this slope M. It could be the difference in the y coordinates for Q and B. And it can also be the difference in the y coordinates for Q and A. So all of these are the same. And comparing them, we should get some nice relationships between A and B, and hopefully we can get some integers out of this. Okay, so, well, what should we do? A over, actually, let's I don't even know what's best here. Well, let's say A over A minus B is equal to 4 over 13 minus B. So that tells me 13A minus AB is the same as 4A minus 4B. So 9A is the same as B times A minus 4. Okay. Maybe instead we should regroup and solve for our A's. That way we get A in terms of B. It might be a little nicer. So We'll put the 9a minus the ab over here is equal to negative 4b. Take out a factor of a, so negative 4b over 9 minus b, that's a. Okay, and so if we want a to be an integer, there's certain things that we might be able to conclude from there. So that's just comparing these two. Now what if we were to compare these two? So 4 over 13 minus b is the same as 4 minus a over 13 minus a. Okay. Also, just thinking about it, notice that we already have one instance where the a's and b's are integers. It's a straight line. If it's a line going straight up, and that might be the only time that happens, because 13 and 4, I don't think they're going to play very nice. Multiplying both sides through, we'll get 52 minus 4a is 52 minus 13a minus 4b plus ab. So the 52s will cancel out. And let's bring all the ab's over to the side. So we'll get 9a minus ab is negative 4b. Rats. So we haven't learned anything new because it's going to give me the exact same relationship. Okay. Let's think about this. Now, a and b are positive real numbers. They tell us that up here. So we could use that fact. Now, a has to be positive, but so I'm abandoning. I'm not going to compare the other two because I suspect I'll get the same sort of relationship. Oh, maybe not. Maybe there's a squareds in there. No, the a squareds I think will cancel out. Well, we'll come back to it if I'm missing something. But so I guess we just have to look at this relationship here. A is negative 4b over 9 minus b. Now, b is greater than 0. So negative 4b is less than 0. But a is greater than 0. So that tells me I have to at least divide by something that's negative if I'm going to get a positive. Because we definitely have something negative on top. So we need to get something negative on the bottom. So b has to be greater than 9. Great. Okay, and we also need 9 minus b has to divide negative 4b. But 9 minus b also automatically divides any multiple of 9 minus b. So we can say 9 minus b has to divide 36 minus 4b. But since 9 minus b already divides negative 4b, both of these together allow me to conclude 9 minus b must divide 36. There we go. That's going to do it. So 9 minus b is negative, and 9 minus b is a factor of 36. So what are the factors of 36 that are negative? Negative 36, negative 18, negative 12, negative 1, negative 2, negative 3, negative 4, negative 9, and negative 6. There we go. So if these are my 9 minus b's, what would I have? My b minus 9 would be just negative everything, so 36, 18, 12, 9, 6, 4, 3, 2, 1, and b would be just add 9, so 45, 27, 21, 18, 10, 11, 12, 13, 15. Now, does each one of these give an A? They should. So that should be 2, 4, 6, 8, 9 different possibilities. And we could pick one or two at random just to make sure if we wanted to. But I'm confident in the work. All these b's are integers, but we could double check what's negative 4b going to be. Well, it's negative 180, and then a, I'm going to divide what's up here, what's down here by what's up here. So negative 180 divided by negative 36 is 5. That's a positive integer. We'd have negative 108 divided by 18. Both of them are multiples of 9. So this is negative 2 times 9, and this is negative 12 times 9. So we should get a is 6. Negative 84, so that's 7. Negative 36. No, whoops, wrong thing. Negative 72. Negative 40, negative 44. So this would be a is 40. This is a is 22. This would be negative 48. So that would be 16. Negative 52. So that would be 13. Here's where they're both 13. So that's a nice boost of confidence there. 10 and then 8 here. So these are my possible values for A. Now, did they ask for how many, or did they ask for all pairs? For how many of these line segments are A and B both integers? Well, we did a little double check, although we could have answered a while ago. There are 9 lines with Q on AB, so that A and B are both positive integers. Okay. They told us it was positive earlier in the question. We would get more if you could allow B to be negative, and even B being equal to 0, but they said positive up above, so I repeat positive in my answer just to remind them, just in case the marking scheme might be off. That has happened a long time ago in the past on other contests. Doesn't really happen that much nowadays, but it's never something you want to be caught on the wrong end of. Alright, so that finishes up C2. Up next, of course, will be C3. We are making our way through the Part C questions. Feel free to throw a like on the video, leave a comment if you had a different approach to these questions. Not even necessarily faster or better, just I always like seeing different ways to do questions. And I will see you for more of our 2015 Open in the next video.